So last example, an electronic product takes an average of 3.4 hours to move through an assembly line. If the standard deviation is 0.5 hours, what is the probability the item will take between 3 and 4 hours? Well, unlike all the problems we've done now, 3 and 4 as a lower bound and an upper bound are not exactly 1 or 2 or 3 standard deviations from the mean. So in this case, we cannot use the empirical rule. We have to use the calculator to do that calculation. So the first step when you're doing a normal distribution problem like this is draw a normal curve and make it the best looking bell that you can. Mark the middle as the mean, in this case 3.4, right? Go about halfway down the curve, and that'll be 1 standard deviation to the right, plus 0.5 is 3.9. Add it again, 4.4. Add it again, 4.9. Okay, then I'll go to the left. 1 standard deviation of 0.5 should be 2.9. Then I go to 2.4, then 1.9. Now, what we've been asked for is between 3 and 4. Right? 3 is a little bit to the right of 2.9. 4 is a little bit to the right of 3.9. So that is the area under the curve that we need. So go to your calculator. Second large, 2 for normal CDF. The lower bound now is 3. The upper bound is 4. The mean is 3.4. And the standard deviation is 0.5. Enter, enter, and it looks like 0.67, so 67%. So 67% is in between. Now, in terms of like probabilities, right, because the entire area under the curve is 1, that should have said not 0.67. Okay, so the probability that an item taken at random takes between 3 and 4 hours is 67%.